Start recording. We are live, people. So, I hope you recognize a question like this when you take the AP test. That they tell you, hey, there's water going in something, there's water coming out of something, it's a rate in, rate out. You should know that all the questions are going to ask. Maxes and mins, how much is in the tank, blah, 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 all that crap. Okay? They tell us the rate that water enters is F of T. Okay? Now, the fact that they're giving me a rate in and a rate out here means that they're both going to be like positive functions, probably. Like if they say this is the rate that it goes in, that's never going to become negative. It doesn't make any sense. So the key difference here is sometimes they just give you the rate of change, like the mosquito one. That can be negative. That means we're losing mosquitoes, right? But if it's a rate in, rate out, you got to put those together to make the full rate of change. Okay? Now, they made this a little more difficult because they say the rate that water leaves is G of T, and that changes. But it's actually really nice because G is just constants, 250 and 2000. All right? And then they go ahead and give us the graph of them both. Even though we have a calculator, we can do this on our own. Which curve is this? What function is this? That's F. That's the rate water enters. And then the two lines are the rate that water leaves, G of T. Cool? So when they ask us, how many gallons enter the tank, which function do we need? Just F. Yep. That's not how much is in the tank. We don't care that there were 5,000 to begin with, which, again, you have to make note of. Okay? Actually, before we even get into A, let's readdress this question, I guess is a better plan. They tell us how much there is in the tank, which allows us to find any other amount now. We can find any amount in the tank we want now at any time. Okay? Secondly, they tell me where F and G intersect. What's another fancy name for those two numbers? What? They're not the points of inflection. They're the intersections, but they're not points of inflection of anything. What are they? What's
when it's zero.
When what's zero?
The amount of water in the tank.
When the rate of change of water in the tank is zero. So those are the critical values of the amount of water in the tank. But there's one other critical value which you got to make note of. Where else is the derivative of the amount going to be undefined? At 3. So we have 3 critical values. They gave us 2, and the 1 is 3. So you got to make note that 3 is a critical value here, which kind of a pain in the butt. All right. So that's all the stuff they gave us. A is a fairly straightforward question. You're going to integrate from 0 to 7. You can just write an F of T, dt. Because F is in gallons per something hour, then the integral of F, dt, is going to be gallons. Okay? And you're just do that in a calculator. It doesn't matter if you can do that by hand, which we can't. Hang on here. Get out of here. Okay? So you got to actually enter F in, which is 100 x squared sine. It sure does. Second square root x. Oops. Okay, can we handle that? Make sure we are in radians. I don't know if I am. I am. And then all you do is math 9. We need to integrate from 0 to 7. y1 with respect to x. And it does say round to the nearest gallon. If it doesn't say that, you need 3 places of accuracy. If it does say it, round it or else you're going to lose a point. So it's 8,264 gallons. 8,264 gallons. That's an easy one, right? That's a gimme 2-point question. I think it's a 2-point question, yeah. Or B. It says find the time when the water in the tank is decreasing. Once they start talking about the amount. Matter of fact, I'd probably do this right from the beginning once I know that they give me a rate in, rate out. I mean, I might read through the questions first and see if they ask about an amount. Then I'm going to make up an amount function. Okay, just so I can write it out. I know that the amount function is the amount we know plus the integral from 0 to t of f of x minus g of x dx. They didn't ask me for this at all, okay? But I'm also going to explain in words what that means. A of t is the number of gallons in the tank at time t hours. Everybody feel okay with that? Yeah.
So why would you make it
You could break it apart. It doesn't matter. So you can make the integral from 0 to t of f dt minus the integral 0 to t g dt. That's fine.
They're just the same thing.
Yep.
Okay.
So, and a matter of fact, Tracy, because, do you guys see, even though it looks complicated, do you see how easy it is to integrate g? If you had to do it by hand, you could do it. But the integral of g of t from 0 to 3 is just the area of that rectangle. What's the integral of g from 0 to 3? It's 250 times 3. That's 750 gallons. That means from 0 to 3, we've lost 750 gallons of water. Okay? Doesn't count what's coming in, but that's how much came out. Does that make sense? So even though they gave you a piecewise function to make it seem a little more complicated, this isn't too bad. So anyway, they want to know, when is the amount decreasing? Well, I have a function for the amount now. I made it up. So they're really asking you, when is a prime negative? Okay? And what is a prime of t? Yeah, well, f of t minus g of t. It's not x's, it's t's. Is that okay? And we knew that from the beginning when they told us the rate in and the rate out. We knew the derivative of the amount then had to be rate in minus rate out. But we want that to be negative, and all I'm going to do, because I have a graph of each function, I'm going to try and separate them so I can make sense of this. Okay? This is the same exact thing as this. And I don't think you need to write all of this. Like, you need to explain that f is less than g somewhere. Okay? Does that make sense? Basically what we're saying here is the water in the tank is decreasing if the rate out is greater than the rate in. Easy enough? And they gave you a graph of them both. How nice of them. When is the rate out greater than the rate in? Let's start at 0. Is that happening at 0? Is the rate out greater than the rate in? Yes. It is happening from 0 until?
No.
Not 2. 1.617 hours. And then, I know, it's really nice, right? They give it to you. And then, from 1.617 until 3, the rate in is greater than the rate out. But then at 3, a floodgate opens or something. And from 3 until 5.076, the rate out is again greater than the rate in. Yep, so you're going to write something like this. These are the key things you need. You need this, definitely, okay, as your explanation. And then you just write a little sentence. Because it asks for an explanation, right? Give a reason. Yep. So you're going to write, I'm right over here. From t equals 0 hours to t equals, what was it, 1.617 hours? And from t equals 3 hours to t equals 5.076 hours. Because we're going to put our reason, even though we already wrote it, I'm right here.
I thought T is right there. From 3 to 5.
Hold on, let me. Can I pause this? I think there's a way to pause this. I don't know how. I'll figure it out. It's a new program for me. What?
Can you reference the graph? From 3
I would just say this f of t is less than g of t. Okay? If you do reference a graph, you want to say the graph of a specific function. Okay? Like the graph of g of t. But I think inequalities and functions make more sense. What's up?
T is less than G of T.
Yeah.
From 3 to 5.0.
Yeah, that's what we want.
I mean, F is more.
No.
No, you're looking at the So can we just say that the rate is...
Yeah. Look, f is here. It's below that line. It's below 2,000. Okay?
Oh, okay, gotcha. Can I ask one more last minute question about a different problem?
Well, I'm gonna go through and finish C here real quick, okay? C is the meat of this question, okay? But C is something that we've answered before here. They want to know, when is it the greatest? They want the maximum amount of A. We want to maximize A. I told you there's 3 things you should do here. Dan, I'm gonna do it over here. So this is C. Number 1. Tell the grader you know where to look. We need A prime of t to equal 0. Or we need A prime of t is undefined. That happens at 1.617 5.07. Was it 76? And T equals 3. That's the first part. The second part is you find the amounts there and at the endpoints. A of 0, A of 7, A of 1.617. Uh-oh, I'm running out of room.
You guys looking for a max?
Yep. A of 5.076, and we need A of 7.
So there you would just be looking at the endpoints and the critical values.
Yes.
And
And a matter of fact, yeah, so,
the amount from
yeah, we can cancel some of these out because we're looking for the max, not the min. So the fact that, like, we're losing water up until 1.617 means we don't need to find, oh, you have to write that. You don't need to find this. Okay? Secondly, from 1.617 to 3, we're gaining water, so that's a possibility. But then from 3 to 5.076, we're losing water, so we don't need to find that either. You can, it's not wrong to, but it's going to save us some time if we don't find those. So we really just need to find 0, 7, and, oh, I skipped one, 3. That's what this is supposed to be here. This is 5,000. I'm going to do this in order. A of 3 is 5,000 plus the integral from 0 to 3 of f of t. And it is minus g of t.
Yeah.
But I'm just going to put, instead of g of t, I'm going to put what g of t is on that interval.
Okay.
Does that make sense?
Yeah.
You can also just find the area under g and do it separately, which I'm going to do for the 7 one, just show you what that looks like. Okay? So this is 5,000 plus. Actually, you don't even need to write this out. You're just going to do this on the calculator, right? So A of 3 is 5,000 plus math 9 from 0 to 3 of f of t, which I put in y1, minus 250 dx. And we're getting something. Oh, man. I put 500. It's supposed to be 5,000. Second entry. Let's go all the way back.
After you're done with this, can I ask a question?
You can ask all the questions you want. All you gotta do is add 4,500, but let's just do this. 5126.591.
So since it says in there's gallons, could you just round that up?
Yeah, I'm gonna write that out now. Actually, yeah, you can just do 0.7. It's fine right here. Okay, so that's gallons there, and then we also need at 7. But because g switches, you can either do two different integrals. You can go from 0 to 3, and then 3 to 7, and change this 250 to a 2,000. Like, here, let's write out both ways. You could do 5,000. We can actually use this number here we just found,
Yeah.
but so and go from 3 if you wanted to.
So you can do the 5,000 plus the number you just got, and then the integral.
It's not 5,000 plus the number I just got. It's the number I just got plus the integral from 3 to 7. Because we know this at 3, right?
Yeah.
So you got to start at 3. Or you can do 5,000, 0 to 3, f minus 250, plus the integral from 3 to 7, f minus 2,000. Oh, man, I'm running out of room. Does that make sense?
Yeah.
Okay. Alternatively, since we're not doing these, I'm going to erase these. You could also, again, you don't have to do all of these. I'm just showing you different ways.
Yeah.
You could also do, or you could do a of 7 equals 512, and I probably use the exact decimal I got here. 5126, 590, 5126, 6.5, I forgot already. 590801, 590801, plus the integral from 3 to 7, f minus 2000 dt. That'll find it. Or a of 7 could be 5,000 plus the integral from 0 to 7 of just f. That's how much water came in, minus the integral of g of t. But we can do that just by finding the area up here. So look, the area under g from here to here is 750.
Yeah.
And then this is 2,000 from 3 to 7. So what's the area in there?
2,000. So 2,000 times 4.
Yep, which is
8,000.
8,000. So all in all, we lost 8750 gallons. Every single one of those is going to give me the same answer. Doesn't matter which one. Okay? So I'll do second Oh, that's what we just got, right? So that's our answer. I don't know why I just did it again. Then I would do plus math 9. Since it's already in my calculator, I would just do the integral from 3 to 7 now. Is that okay? Of y1 minus 2, 1, 2, 3. Which is something. 45, 13? 45, 14.
Yeah.
Okay. So the maximum amount is 5127, and you're going to write a nice little thing here. I'm going to type it out because my handwriting is not the best. The maximum amount of water is 5127 gallons at T equals, was it 3?
Yes.
3 hours. I checked the endpoints, 0 and 7 hours, as well as, we didn't check all the critical values though, because we didn't check 2 of them.
Okay.
So we checked because we're looking for maximums, and also as well as where a prime of t, which I'm allowed to call it,
Yeah,
changes from positive to negative, which is t equals.
3 hours.
Okay?
I love calculus.
Great.
Take calculus.
Excellent. Are you making fun of me?